Okay, let me review a little bit about this section. So we are going to in this section, we are looking at the knowledge base recommendation system. So the knowledge base means we want to find constraint. We want to find some requirements from the users, and here we are going to apply that requirements based on the items catalog or based on the items specification. So there are many constraints that we already learned. We have the very simple constraint satisfaction problem. So we can just use if function. And then we can also do the diagnosis. So when we do the diagnosis, in this case, if the requirement is unsatisfied. Unsatisfied means if we cannot find any result from the constraint, so we can do something. The first is the diagnosis. In the diagnosis, we try to find the conflict set. So the conflict set means we want to find where is the requirement that limit the result. So after we know that, okay, some requirements should be omitted, some requirements should be removed in order to give the result. So another, this is one of the methods. Okay. You can use the method to remove the conflict set based on the two requirements, the R1 and R2. So if we remove R1, then we still remain R2, and then we look for another possible requirement that may be a conflict. And then, if we remove R2, then it means the D or the diagnosis are R1 and R2. So in this case, the diagnosis is R1 and R4, and so on. So we will do for every conflict set, and then we need to find the diagnosis result. So once we have this diagnosis result, it means we can let the users know this conflict set may give no result to the users. So the other way that we can do for this conflict set is to use the min-relax algorithms. So the min-relax algorithm is for determining the complete set of minimal diagnosis. So minimal diagnosis means we need to find the minimum requirement that can give a result to the users. So in this case, if you use R1, you can have a solution. If you use R1 on P2, it is not available, or it is no result. It is, we can say, it does not satisfy with the requirement of P2, P3, P4, P5, P6, P7, and P8. If we have this requirement, then it satisfies on the P2 only. If we use the R3 requirement 3, so it satisfies with P2, P3, P5, P6, P7, and P8. If we use the R4, it satisfies P1, 1, 4, and P8. Then If we have requirement R1 and R2, so this is conflict set because we cannot find any result. If we use R1 and R4, then we can have one result and so on. So using this min relax algorithm, we can directly determine the complete set of minimal diagnosis. So the goal is to identify the diagnoses that are minimal. In some cases, we can repair. So repair means we can ask the user to make some changes. Let's say the user want to find a camera and the price should be less than 150. But actually, only one option is available. So some kind of repair means maybe the sales will ask, is there any possibility to increase the price? Is it possible if you buy a product with price 200? Or is it possible if you change the optical zoom to 10 times? Or is it possible if you omit the R3? How about if the camera has no sound? And etc. So we can have the repair. So the repair means we need to find some kind of query that can fit or that can give the result. So we need to find the possible adaptation. The possible adaptation means we need to find the diagnosis. So this is the diagnosis result R1, R2, R1, R4, and R2, R3. And then we can try to this one. I think this one, it should be like the symbol is why it doesn't appear. I think this one should be minus. Okay, like this one. So I want to know if I use the diagnosis 1. So if I use the diagnosis 1 means let be the user requirement minus by the diagnosis 1. So the requirement is this one. So if I omit the D1, D1 is R1, so I remove R1 and then I remove R2. Then it shows this result. I can just have the sound equals to yes, waterproof is yes. So sound is yes, waterproof is yes. It means, if I remove based on the diagnosis 1, I can get this result. So this is the repair one. Now let's see if I do repair with the diagnosis 2. The diagnosis 2 is R1 and R4. So R1 is price, R4 is waterproof. Yes. So I would like to check what is the result if I have R2 and R3. So if I have R2 means optical zoom is 5 and the sound is Yes. So this is the result after we repair the diagnosis. After we repair the requirement based on the diagnosis. If we repair based on the diagnosis tree, then the requirement minus the diagnosis tree. So the diagnosis tree is R2 and R3. Then I will check the R1, which is the price is less than 150. And then the waterproof is yes. So this one. So after we do the repair tree, yeah, this is like the requirement from the user after we repair it. So there are some other ways to find the possible requirements. In this method, it is based on the ranking of the items. Here we can say we want to have the multi-attribute. Multi-attribute means more than one attribute. It is a multi-attribute utility theory. So each item is evaluated according to a predefined set of dimensions. A predefined set of dimensions. So it means we want to have some more attributes that provide an aggregated view on the basic item properties. So this aggregation view, we want to see how, for example, the quality. What is the quality of the product? Or maybe the other is about the economy of the product. It depends on the items. In this case, because the product is digital camera, then we can say that two attributes can be the multi-attribute utility theory. In this case, quality and economy. And then the user, this one is a little bit takes time. It takes time because the user need to give a kind of rating based on the quality. If the product price is less than 250, what is the rating? So if the rating is in between 1 until 10, the higher is the better, then the user can determine. Okay, if it is lower than 250, maybe the quality is not that good. So the user gives score. How about the economic? Oh, of course, it is more economic because the price is low. So the score is high. But if the price is more than 250, so the quality will be good. But from the economic perspective, it is not good. So this score is from the user. And then we also get the user feedback for every attribute, MPix, so the megapixel, whether the camera has the optical zoom, whether the LCD size affect the quality and the economy, whether the camera can record a movie or not, sound, waterproof. So we try to get the score from the user. So that's why it is like, you need more time to get the score first, and then you can calculate. And then, yeah, we can define what is the customer specific interest. So we can ask, okay, customer one, what do you want? Do you want to have more quality or more on the economy? Okay, the customer one said that, okay, I will just focus on the quality, 8% of the quality, and then maybe 20% on the economy. Based on this result, you can calculate. How to calculate? So, yeah, you can calculate if the product one, what is product one? So, yeah, this is the data. Sorry, I need to. Oh, I cannot put everything here. Okay, let's see this one. So the product one, the price is less than 250. It means, okay, for the quality is 5. Okay. For the economy, it is 10. What about the megapixel? The megapixel is less than or equal to 8. Then the score is 4 for the quality. And then for the economy, it is 10. Okay. So we can sum all the score. The optical zoom is 4. 4 is, the quality is low, the economy is good. So for every number here, for the quality aspect of the product one, we will do the summation. 5 plus 4 plus 6 plus 6, 3, 7, and 10. So maybe the LCD size is 2.5. So with 6, we have a movie. What is the movie here? We have no movie. So because it's no movie, this is 3. And then sound, we have no sound, then it's 7. And the waterproof is yes. So 10. So it is 5 plus 4 plus 6 plus 6 plus 3 plus 7 plus 10. So this is the summation result, 41. And what about the economy? Yeah, we will check also based on the product one. The product one for the economic, it is 10 for the megapixel, it is 10 for the optical zoom, it is 9, and so on. So we will get the value 65 for the product one. Then how can we calculate the utility? Yeah, I give you example. Because we already have the requirement from the user. Okay, let me delete this one. We have the requirement from the user one that the quality will give you 80% and the economic will give you 20%. Then I will just calculate. Let's say this is the for P2. Okay. For the P2, we have the 49 multiplied by 0.8. 0.8 is the weight of the quality from the user one, and then we have 64. 64 will be multiplied with 0.2, which is the ratio of the economic. So we will get the result 52. So 52 will be here. So we calculate for all the items for P1 until P8, we get the score for customer 1, we get the score for customer 2. And then how can we give the recommendation? The higher is the better. It means we can make rank. This is the rank. Rank number 1, rank number 2, rank number 3, rank number 4, and so on. It means if I would like to give you top 5 items, it means I will give the rank number 1, rank number 2, rank number 3, rank number 4, and rank number 5. This is the rank for customer 1. What is the rank for customer 2? This one, because this is rank number 1, this is number 2, 3, 4, and 5. Okay. So what we learned in the previous one is the constraint base. So we are going to learn another case, it's another types of knowledge-based recommender system based on the case base. Okay, I think let's have a break. Okay? We'll continue after the break.